And the other topic is complexity analysis. So complexity analysis provides a hardware independent way to measure efficiency by counting elementary operations. Let's see with example. Let's consider this program and calculate the time complexity of this code. Okay, so as we see in the previous rule, so this is the assignment operation. So we will give, or this will take only 1 unit of time, and this one also will take 1 unit of time, and this one also will take 1 unit of time, and this one also will take 1 unit of time, and this is assignment, I mean output operation, input output operation, so it will take 1 unit of time. But here we have assignment operation and also addition operation, right? So we have to give the unit 1 unit of time for each operation, so 1 plus 1, right? Okay, let's sum up. So T of n, which equal to, or time complexity of the function, which equal to 1 plus 1 plus 1 plus 1 plus 1 plus 1, right? So 1 plus 1, 2, 3, 4, 5, 6. So T of n of this code is 6. So it is a constant time. It is a constant time. It will take constant time. So this is the time complexity of this program. Let's consider the other example, which is this one. So to calculate the time complexity of the function or this program, so this is assignment operation, so it will take 1 unit of time, and this also input output operation or output operation, so it will take 1 unit of time, and this will take 1 unit of time, and this will take 1 unit of time. This is a loop statement, I mean the condition statement, so it will take n plus 1 unit of time, and this will take increment operation, so it will iterate n times, and this will take, there is assignment operation and also addition operation, but this statement is find inside the loop, so it's iterate n times, so 1 plus 1 times n, right, which means 2n. So this one is function return, so it will take 1 unit of time. But let's see by giving example how this loop statement iterate this amount of time or this unit of time. So let's assume the value of n is n which equal to 5. Let's make n is 5. I is what? I is 0. Then in the first iteration, I is 0 and n is 5. So it will execute, right? It will execute. So 0, 5. So it will execute. This statement is executed or checked. And after that, this statement will be executed. Then after it will, this increment operation also executed. After that, it will goes to the condition to check if the value of I is greater than 5 or not. After that, the value of I is 1 because it incremented by 1. So it will be compared with n, then I is less than n, which is 5. So it will be checked again, and the value of I is also incremented by 1, and the value of I will be 2, then 2 less than n, which is true. And the value of I will be incremented, which is 3, then 3 less than 5, which is equal to true. And the value of I is, or the value of I will be 4, so 4 less than 5, which is true. And the value of I is 5, so 5 less than 5, which is not true, right? Which means if this statement is not true, at this iteration, this statement will not be executed. This and this statement will not be executed, but this condition is checked, right? This condition is checked, which means this condition or this loop statement will be checked how many times? 1, 2, 3, 4, 5, and 6, right? Which means the value of n is 5, then this statement is checked 6 times, which means this statement is checked n plus 1 times. But this statement, how many times it executed? Which means at this point, when the value of I is 5, then this statement is not executed because the condition is false, so it is not going to execute this statement. So this inner statement is executed 1, 2, 3, 4, 5 times, which means n times, here n times. And also this increment statement, this one is executed n times also, n times. So to sum up this, 1 plus 1 plus this one, 1 plus this one, inside the loop, 1 plus n plus 1, increment plus n, plus this statement, which is 2n, plus return operation, which is 1. So 1 plus 1, 2, 3, then 4, 5, 6. So 6, let's add n. N, this 1, 2, then 2. In general, 4n. 4n plus 6. So this is the correct time complexity for this statement. So we can do just like this. This is another example, just as we do in the previous example. This one will take 1 unit of time. It will take 1 unit of time. This one will take 1 unit of time. This one will take 1 unit of time. We start the value of I from 1, and there is less than or equal to symbol, so it will take n plus 1 unit of time, and this one will be take 1 unit of time, and this one will be n into, because this whole statement will be executed n times, and this addition operation, this assignment operation will take 1 unit of time, and this addition operation will take also 1 unit of time. So this is multiplied by n. So 1 plus 1, so 2n. Then this return operation will take 1 unit of time. So we can simply add this one, t of n, which equal to 1 plus 1 plus n plus 1 plus n plus 2n. then plus 1. So T of n, which equal to 1 plus 1, 2 plus 1, 3 plus 1, 4. Then 4, then n to n, which is 4n. 4n plus 1. I mean 4n plus 4 is time complexity for this statement. So we can simply do just like this one. The other example of here is analyze the following code fragments, which is it is a nested loop code fragment. So let's analyze this one. So in the outer loop, this initialization will take 1 unit of time, and the condition here is it will take n plus 1 unit of time, and the increment statement will take what? N unit of time, right? This increment statement will take n unit of time. When we consider the inner loop, for each iteration of I, for each iteration of I, this initialization will take n unit of time, and also this initialization, or I mean this condition, will take n into n plus 1 unit of time, n into n plus 1 unit of time, which is equal to n square plus n times. And this condition, I mean this increment operation, will take n into n times, right? N into n times n, which is equal to n square times. This will take n square times, and the output operation here by itself, it will take n into n times, or n square times. So to calculate the total time complexity, T of n, which equal to, we can simply add here 1 plus n plus 1 plus n plus n plus here this into n square plus n plus n square plus n square, right? This is the total time complexity. So which is equal to, we can simply add 3n square plus 4n square, I mean 4n, no, 4n, not 4n square, it is 4n plus 2 plus 2. So this is time complexity T of n, which equal to, just like that, T of n, which equal to 3n square plus 4n plus 2. This is the time complexity for this inner loop statement. So you can simply add some examples just like this, and you can exercise.